Good morning, everybody, and welcome to day 6 of the Aquatic Apocalypse series. I'm actually switching up a little bit. I'm going to actually start with the simulation that's a little bit later in your answer sheet. It's this table here. After you go to this website, I want to show you what we're doing. We want to compare the solubility of these chemicals. And one way to compare the solubility is to track their saturation point. Let me show you how to do that. So here's the program. We will want, in this little box in the bottom left, we'll want to have that checked. And let's go to potassium permanganate, the first one on our list. Notice it's already saturated. We want to adjust the amount of solute so it's not saturated. That is called the saturation point. And I'm going to reduce, and, oops, let's see if I can get it exact. Right. Close enough. There we go. 0.484 is going to be the saturation point for that one. And I'm looking at the rightmost figure there. It's the concentration. And I would write 0.484. What we're going to see is that not all solutions have the same solubility. Some are more soluble than others. Think about this. If it's more soluble, are you going to expect the concentration to be higher or lower? It'd be higher, right? The higher the solubility, the more dissolved it is. So the higher the concentration, at saturation, imagine we're going to dissolve two different substances. One of them is table salt, and the other is chalk, like chalk on a whiteboard kind of idea. It's called calcium carbonate. Well, we already know our solubility rules, and one of the rules is that carbonates like calcium carbonate are insoluble. If we were to add both of them to, let's say, a liter of water, we would notice that more of the salt would dissolve than the chalk would. And if we analyzed the liquid, we would notice that for the salt water, there's a good amount of salt in it, so it has a high concentration. And for the chalk water, the vast majority of the water is just water. All the chalk is sitting at the bottom. So salts have different solubilities. Now, let's move up to the top portion, because I think this might be the area that more people struggle with. First, you're going to take this data and you're going to put it into this solubility curve. Now, I have a curve that I copied from online that I want to look at, and it's a curve that involves more than one substance. So don't be confused by this. This is going to be the solubility of potassium nitrate, but let's take a look at one that has a bunch of different salts on it. Okay, so let's focus in on two different salts. Let's look at potassium chloride and lead nitrate. What do you notice about the vast majority of these salts as the temperature increases? Hopefully you notice that their solubility increases. So imagine for a second we had a pot of water. Let's actually say it's a really small volume. And let's say that we added some salt to it. And we added a little bit more, and we stirred it in, and we added a little bit more. At some point it becomes saturated. Let's say that salt that we were using was potassium chloride. And let's say it was at room temperature. So that's around 25 degrees Celsius. What this chart shows us is the levels of saturation at different temperatures. So at room temperature, we could add 10 grams of potassium chloride and it would be unsaturated, meaning we could dissolve more in it. And I like this this figure. Of course, I think I'm blocking it right now. But there's a figure that shows that you can dissolve more at an unsaturated state. Now let's add 10 more grams. Still unsaturated. Let's add 10 more grams. Unsaturated. And once we hit this mark right here on this line, oh, it's about 34 grams. That's the amount of potassium chloride that dissolves in, and it says it right here, in 100 grams of water. That's the solubility of potassium chloride. If that had been a different salt, let's say lead nitrate, we would have been able to dissolve, oh, it looks to be about maybe 61 grams of lead nitrate in 100 grams of water. The solubilities are not the same. Lead nitrate is more soluble than potassium chloride at 25 degrees. Now let's look back at our potassium chloride. Remember, we dissolved 34 grams in 100 grams of water. Let's say that we heated that solution up. Let's say we heated it up to 80 degrees. So I'm going to drag this line over to 80 right there. Notice that we got to a point now that we're below the line. We can actually add more potassium chloride in. How much more? Maybe like, oh, I don't know, 4 more grams. We can add 4 grams of potassium chloride to reach saturation, the point at which we can't dissolve any more potassium chloride. So what we can say is that for the vast majority of these salts, if we increase the temperature, we increase the solubility. Let me ask you one question that's going to get you a good start on this worksheet. The question is, let me come up with a good question here. Will 60 grams of lead nitrate dissolve in 100 grams of H2O? First, let's just stop there. If this was the question, will 60 grams of lead nitrate dissolve in 100 grams of H2O? You actually wouldn't be able to answer this question because you need to know what temperature we're talking about. Turns out lead nitrate, even though it's fairly soluble, won't dissolve in very cold water, like solid water, right? We need liquid water, so we need a certain temperature. So I'm going to add something to this question. Let's add a temperature of 10 degrees Celsius. So we are focused in on our temperature and the amount of lead nitrate. So back up here, 60 grams is right there. 10 degrees is right there. I'm going to draw that point. The question for you is that above or below the line for lead nitrate? It's above the line, right? Because lead nitrate is here. Anytime we're above the line That is a saturated solution, meaning it can't dissolve any more lead nitrate. And if it's below the line, as in like everything down here for lead nitrate, that's what we'd call an unsaturated solution. So we could say our answer for this one would be no. Not all 60 grams dissolve. It turns out it's more like 45 grams. 45 grams dissolves. And then PbNO3 is saturated. So we add 10, 20, 30, 40, 45 grams. And at this point right here, we get a saturated solution. And everything we add beyond that point is going to cause it to, it'll sit on the bottom. So of that 60 grams, 15 grams will sit on the bottom of the glass. Here's a little visual for you. We've got our beaker. We've got our 100 grams of water. Let's call this our lead nitrate. There'd be 15 grams of PbNO3 there. And the other 45 would be dissolved, and let's use that word that you learned last in the last day of this. 45 grams dissolved in solution. We have our solute, lead nitrate, we have our solvent, water, and we've made a 45 gram solution, and it would have some sort of concentration to it. If you have any questions, make sure to email me or check in during my office hours. Have a great day.